Welcome to the project demonstration of battery management system along with SOC calculation and displaying on LCD. So in this version we added the voltage sensors which are ready made and which is the potential divider circuit of 35K and 7.5K. And next here in previous version we have did SOC calculation, but we didn't display on the LCD, and in this model we are going to display in the SOC by calculating the state of charge in Coulomb accounting method. So how we are going to calculate that means, initially when we switch on this kit, so the microcontroller will capture this battery pack's voltage, and then after certain time, around consider of 20 to 30 seconds of duration, then it will check with the again current voltages. So based on this it will calculate the state of charging, and nothing but in terms of percentage that will be displayed on the LCD screen. So it's keep on counting that. So for every next onwards for every 3 to 4 seconds it will calculating that and displaying on the LCD. So the remainings are like same. Overcurrent will be identified with the help of the temperature sensor whenever the battery is getting heat up, and under voltage and over voltage are measured with the help of these 3 voltage sensors. So whenever the voltage is below 10 volts, then microcontroller will switch on the respective relays to charge the respective battery pack. And next, whenever the voltage is above 13.5 means maximum voltage reaches, then again the respective relays will be switched off. So here we are using the electromagnetic relays to control the voltage flow from charging circuit to the batteries. So the main power flow is we are going to provide the 230 volts input here. Transformer will step down the 12 volts to the 12 volts AC, and that was input to this regulated power supply board. On this board we have 3 stages. One is rectifier, so bridge rectifier with the help of these 4 diodes, and this capacitor will act as a smoothing capacitor so that we will remove the pulses from the pulsating DC, and that is going to get 12 volts, so that will be given to the charging voltage to the batteries through the relays. And so we are going to provide the 12 volts DC input to the 7805 regulator, so we will get 5 volts DC, so which is the operating voltage for our microcontroller along with LCD display and buzzer and LM35 temperature sensor. Right, so let us see the demonstration. So there will be a welcome message on the LCD screen. Right, so now the system is displaying the battery voltage along with temperature. So as of now it's still calculating the SOC values. So meanwhile we can go with temperature increment. So when we increase the temperature with the help of any heating object, so when it crosses 50 degrees centigrade, then the system will give the audible alert as high temperature due to heavy load or any short circuit happen inside the battery packs. And when it comes down to normal, right, so here the SOC is calculated. Now in this version we place the switches instead of unplug that. So these switches are used to disable the battery pack. So now it is on above and below off. So I switched off the battery pack 1, disable that, right. So now the battery pack charger got switched on. So right, so this battery pack 1, 2, 3 and the chargers are connected in this manner 1, 2, 3. So let us see, disable this. Right, so I'm enabling this by switching on. So as we can observe, the same appearance happening in SOC also, because of the respective battery pack got disabled means the system will measure the voltage, whether it's disabled or enabled, it doesn't know that, but it will check the voltages. When it is coming to the 0, then it will calculate the overall SOC, state of charging, right? And I'm enabling that, right? Thank you.